So, Einstein said that time is an illusion, albeit a persistent one. And we're also focused on events that might have happened in the past or worried about what may happen in the future. But today I invite us to focus on the one point in time free of those illusions. And it is there I believe we'll find magic. Now I have a watch here. I'm going to take it off. I'm going to undo the dial. I'm just going to twist it around a little bit to get some different times going, okay? And in fact, what was your name? Can you twist that dial around until you're satisfied? Right there? I'm going to lock it in, okay? I'd like you to memorize the time, give or take on there. More or less. You got it? You can see it too, okay? Are you a righty or a lefty?
I'm a righty.
Can you put your right hand down? Is that okay? Like this? Go ahead and squeeze the watch and just hold it there the entire time. Do any of you have a ring? You don't wear a ring by any chance. You don't have a ring either. Cool. Is that a normal ring?
Sure.
Could have been your ring.
Could have been my ring.
Could have been your ring.
Yes.
Everything that's ever happened is happening now, or ever will happen is happening right now. And time is merely a function of perspective. In fact, general relativity tells us, take a little step back for me, so that's good, yeah. That if an object, such as this ring, were to approach a strong gravitational field, to an observer looking at that object, it would appear as if time had slowed down. From the object's perspective, it would still be just going normally.
Right.
To an observer looking in, it would appear as if the object stopped. As if time stopped for the object. From the object's perspective, it would still be going. Here, you want to see? Now, furthermore, if I'm able to sink my mind down to the level of the unified field, I could actually increase the gravity below this coin, making it seem as if the coin is stuck in time again. Now, since gravity is curved space, if I could reverse the space-time curvature, gravity could go up. You want to try again? Beautiful. Now, special relativity says motion through space affects time, okay? Watch, watch, watch. Come here, come here. Take a card. Show everybody what it is. You see it? Okay, step back a little bit. Can you see it? It goes in about halfway into the pack. And it's definitely not this one, yes? No. Can you see the cards going into my pocket? Genuinely, yes? Now, it is postulated, let me get them nice and deep in there. It's postulated that if anything with mass were to travel faster than the speed of light, it would break the so-called time barrier, thrusting itself back in time. So we're going to test that theory, okay? Watch the card. I'm going to move faster than the speed of light. And you can see I go back 5 seconds to when I had the deck in my hand. But look, I was actually able to stop short and leave one in the pocket. But watch, watch. If I place it back in the deck and I try to restore the timeline, you can see now that I'm left with only this card. And all these are back in the pocket, which means this must be a probable past, and you're all different people. Okay? But what you guys didn't notice is that I actually traveled back all the way to the beginning, to when I showed you the time on that watch. And I stood behind you, and I saw myself showing you the time on that watch, and the time I saw was about 1:35. Is that correct? That's correct, right? But listen, 1:35 here is 7:35 in Egypt, and 7:35 in Egypt is 4:35 in Australia. So time, in that sense, is really just the construct we invented to function, for practical function. It is when we forget this that we begin to feel bound and constricted by time. See, we would all do well to remember that in reality there is no time.
What?
The present moment is all there is.
하늘이 없어졌어. 와우.
It is when we forget this that we start to really feel bound, constricted by time. See, we would all do well to remember that in truth there is no time. The present moment is all there is.